welcome back to my YT channel for another live streaming regarding chemical separation process, specifically distillation. So we talked a lot about the definition, the principles, some equations, formulas to be used, the criteria or the requirements, how to use this Machiavellian method in determining the number of stages, trace, like that. We introduced to you the equation and formula for the stripping line or the stripping section. Okay, the rectifying line or rectifying section, like that. The feed line also, which is the small letter Q. So, and now we introduced already last 3 days ago or last 2 days ago. Okay, the formula of the material balances. With the overall material balance, what comes in will be equal to what comes out. Okay, assuming there will be no losses of wasted energy or any diffraction loss will be zero, like there will be no wasted energy to the environment, like that. Okay, so assuming that the flow is steady state flow in equilibrium process, obeying the conservation, the law of conservation of energy and the law of conservation of matter in general chemistry lecture, something like that. Okay, so after the overall material balance, we need also to know the component material balance, and somewhere along the way, if the problem in distillation also involves a lot of energies, and we'll be able to link that with thermodynamics laws, the zero law, the first law, the second law, the third law of thermodynamics, and a lot of laws could be also correlated to this separation processes in unit operations, not limited only to that particular topic at present, but we need also to what they call as one correlate and we link that for the previous also equations and formulas in our let us say minor science subjects, specifically chemistry and physics. Okay, most of the times really it's gonna be like that. Okay, so separation processes, guys, we need to understand the phase changes first before we can understand really the different separation processes, guys. Okay, so we know what are those requirements to have that separation processes. Most of the times we need to deal with physical properties and characteristics of substances or matter, which are solid, liquid, and gas. Something like that. It's gonna be like that always. So this is a substance that comprises of three phases. Okay? Something like that. So there's no limitation. All materials exist in the universe and all materials exist or within the planet is already called technically as chemicals. Get a point? Because natural elements, natural non-metals in the underground, Earth's crust or soil is already made up of minerals, and minerals are also chemicals. Okay, we will not limit our understanding that the chemicals are only what you see in the laboratory. Okay, it's not like that. It should be liquids like that. No, it's not like that. So varying or variants, so many variations of chemicals, and then we can see this every corner around us. The chair, the laptop, the mobile phone, the pillow, okay, the Tupperware and everything. So these products really, guys, are made up of physical separation processes before we can produce the products. Usually, the conversion of raw materials to useful products. Okay, so we will just understand it a little bit, not really that detailed. Okay, so we will just know what's really going on in the material balances. Okay, so I already chose one problem that doesn't involve, guys, the Machiavellian method in distillation because it is very lengthy, right, to connect intersection plotting points of vapor and liquid. So we need to avoid that one because very lengthy. Anyway, we have now a clear idea that's gonna be like this in distillation, a separation, vapor and liquid. And here comes heating in the bottom part of the distillation unit. And here comes the evaporation, the vaporization, like that, and the condensation will be at the top. Okay, the cooling system will be at the top, and we have the condenser at the top to produce an overhead product, and we have the reboiler at the bottom to produce our bottom product or no, not distillate, condensate. So we need to say only two physical processes, guys. Condensation and evaporation. Okay, we need to evaporate the liquid. Okay, something like that to produce a vapor. So that would be our condensate. And we need to condense the vapor to produce a liquid, and that is our distillate. Okay? Something like that. So heating and cooling ragid siya, guys. And there's no losses. Meaning there's no heat loss, there's no heat of mixing. So heat chuva chuva chu chu is negligible. Okay? Negligible meaning not really that have a great factor for this. We assume to be there's no heat loss, ganun siya, and there's no such issue for the what happens to the energy like that, like that. So it's not like that. Okay, and then of course the latent heat of vaporization and the latent heat of condensation are negligible and constant as well somewhere along the way. Okay, so the vapor phase will be in thermal equilibrium to the liquid phase, something like that. Okay. So in a distillation unit, we are having the stripping section at the bottom. The center will be our flashing zone section in the feed. Mixture is gonna be like that. And the upper portion will be our rectifying section. Okay? Okay, in the rectifying section, the vapor goes up. Okay, and the liquid goes down. Okay? Like that. So this is really a study through the differences of the boiling points and the volatilities of the mixture, or shall we say liquid to liquid, like that. It depends on what phase you are using, right, in your distillation. Okay, and then here comes you have the source of your feed coming from the tank. It will be feed to your distillation unit, like that, so choo choo, and it will produce overhead product and bottom product. Okay, now, okay, let's do the problem. Gosh. Diba? So this again, this problem is taken in the BS or Chemical Engineering Board Examination 1996. Okay? In the Philippines. Okay, not in other countries. Okay? So it's gonna be like this. I will read first. Okay, a liquid mixture containing 45% benzene and 55% toluene by mass is fed to a distillation column. A product stream living at the top of the column overhead product contains 95% B, and a bottom product stream contains 8% mass of the benzene fed to the column. Meaning 92% of the benzene leaves with the overhead product. The volumetric flow rate of the feed stream is 2,000 liters per hour, and the specific gravity of the feed mixture is 0.872. Determine the mass flow rate of the overhead product, bottom product, and the mass fraction of benzene at the bottom product. Okay. It looks like difficult, right? So, of course, if you will see this kind of problem for the very, very first time, you don't have an idea how to solve this. It looks like difficult, right? Really, even me, it looks like difficult. But when you scrutinize, assess, analyze, and evaluate this logically, having in mind the different formulas, equations, and then you can really solve this patiently, okay? Though it looks like difficult. This is not really easy. It's somewhat average, a little above average kind of problem. And this is not also difficult, a little bit above average kind of problem. This involves tricky terminology, tricky, T-R-I-C-K-Y, tricky, meaning it will trick the students and the examiners for this kind of problem. So again, you should have critical thinking and wild imagination before you solve this problem. Of course, you have also the solid foundation of your stock knowledge of physics equations, chemistry equations, and your lower minor subjects in your engineering course, something like, particularly related to science. Okay, and this will also involve a little bit of mathematics, mathematical operation, but it will never go to calculus. It will never go also to engineering. What do you call this one? Differential equation. Nor it will never go to the advanced engineering mathematics. This only involves a complementary of trigonometry, and a little bit of geometry, a little bit of analytical geometry, and a little bit also of algebra. Okay, so we will link that here, okay, in this problem. Most of the times, right, it's really mixed with mathematical operations, minimum algebra, and trigonometry. Okay, like that. But if you want to solve this in, differentiation and integrating, you can do if you're very, very, clever and adroit in solving those kinds of problem, in doing calculus thing, then you can solve. As long as it will derive, it will obtain the same answer. That will not matter. But for us, that we are not really good in mathematics, average, then we don't have to do that because it will put headache in our brain cells to do that. Okay, especially it needs a higher level of mathematical ability to do that. Because there are also students and examinees who have a very high, mental ability or, mathematical ability. Okay, so they will have shortcut method, straightforward doing the solution so that they can obtain the answer. But sad to say, not all blessed with that kind of mental ability. Okay, so most or majority only having average mental ability. Okay, so we go to the proper way of solving, okay, in a traditional and conventional way of discussing how to solve this kind of problem. Now, the first step is you need to troubleshoot or to obtain what are being asked, meaning the required. Number two, you need to elaborate, or you need to, what do you call this one in English? Deduce. Wow. Another term, deduce, D-E-D-U-C-E, meaning you have to present the data, okay, and the given. And then number three, okay, you need to find out what are the applicable formulas and equations to be used. Number four, if there is a need to draw, to illustrate, then do that to help solve the problems easily. So actually there are only four steps in problem solving. First, troubleshoot and obtain what are being asked in the problem, which are the required. Second, we need to, obtain from the problems the data and the given. Number three, we need to use the appropriate or suitable equations and formulas to be used. Okay, number four, we need to illustrate or have some drawings in order to understand further the problems, especially if the problem is a complex one, then you have to draw, illustrate, or to sketch, to know what's going on, to help understand easily. Okay, only four steps will do. Okay, the rest is no longer that important. For example, you have to scrutinize word for word the terms in the paragraph, and then you have to find another terms. It's easy for you. That's a minor technique only, huh? Okay. So because if we have several terms in our brain cells, we can understand really what is that technical term, and we can apply that one, something like that. For example, distillate. Distillate is also an overhead product, like that. Okay. For example, condensate. Condensate is also a bottom product, something like that. So if the problem will change that to other term, you cannot understand also. And sometimes also, uh, the distillate will be generally called as an extract. Extract, meaning you extract that distillates in the upper portion in the condensation operation or condensation process. Sometimes it will say, what is the extract in after condensing the, like that chupa-chuchu, the vapor. Ganon. So, what is the extract upon ganon siya hitting the liquid? So, extract also is a general term in both distillate and condensate. So, sometimes it will be used also in the problem. Okay? So, though general, but it will be specified what is the extract in the upper portion of the distillation unit upon going out in the condenser. And then you are dependent only for the word distillate and overhead product. So nga. Okay? So dapat we know the terminologies also. Other terms, aside from the common terms that our instructors are using during their discussion proper. Okay? In our curriculum, subject to subject, something like that. Okay? Just kind of, or if the instructors are not doing that for you, then find out for yourselves. Okay? To really find another terms that which is equal to that particular term, which is not common na talaga siya. Okay? You got a point? You get the point or not? Something like that. Okay? So, be careful. Okay? So, something like that. So, this is the problem. Take a look, 5 to 10 minutes, and we will solve this. Very clear or not? Really, very lengthy. Okay, but if you try to computerize this one or encode this, it will become, less in appearance. Wow. Less in appearance. It will not become lengthy based on your visualization. If you try to encode this in the computer, or you know what I mean, right? Comparing when you write it, because I write this also in big letters, something like that, or words, something like that. Okay. Now, atong tagsa-tagsaon, we need to scrutinize and evaluate each quantity per quantity. Okay, what goes in, what goes out, it's gonna be like that, and we need to balance. Okay. The materials coming in and coming out. That's why it's called material balance. Okay? Because we need to balance the materials, what goes in, what goes out. Okay? And later on, component balance, because we need also to balance the component, what goes in, what goes out. And component means also mass fraction, mole fraction, pressure fraction, volume fraction. Okay, there's a lot, guys. Munang maluluka mo siya. Maluluka mo talaga kayo. Pwede sa baya, also in a separation process unit operation, so the problem will say, the volume percent of a solute is like this. Calculate the feed that will goes out. So, meaning to say, oh my gosh, this is now volume percent, or percent by volume. So, you will never go to the mass percent or mass fraction. You will never go to the mole percent like this. Or, for example, it expressed also in pressure. Okay? Benzene has a pressure fraction of 0.33. O, pressure siya ha. So, pressure po imong niya, maglibong din kay ang inyong maestra sa una or inyong instructor sa una, dili mo gamit og mga ingani. Okay? But, a lot of quantities to be applied by ya. Okay? You got the point? This is very important, especially in studying, Le Chatelier's principle, right? Okay, Le Chatelier's principle in 1901. This is a principle that, stating the relationship between the pressure, temperature, volume, concentration, solubility, catalyst, the change in temperature, chuva, chuchu. Okay, and the energy, and also whether it is exothermic or endothermic, irreversible or reversible, could either be spontaneous and non-spontaneous. So these things you should know, because these are very, very basic in science courses, particularly in BS Chemical Engineering. Because kung dili niyo may buwan, mga muti good mo. Okay? I tell you honestly. Okay, guys? This is gonna be, it will help a lot really to solve problems. Okay? So at least we can have very good scores in our chemical engineering and physical and chemical principles coverage in the board examination. Okay? Bahala na lang mathematics. Okay? Basta siguro kung dyan na to ang physical and chemical principles and chemical engineering. Okay? Because, general engineering can be managed also, right? Okay? Because not really that difficult, but sometimes it's tricky also. Tricky. Tricky. This tricky thing, this is the factor that push the students to fail. Okay? This tricky thing or this, this gray area, GREY, meaning it confuses the students by, roller coaster data, and then they try to connect with another topic to topic, and then oh my gosh, this topic is distillation. Why this connect to Henry's law? Why it's connect to Dalton's law of pressure? What's happening here? What I understand, the pressure will only be applied in like this chuba chuchu, an ideal solution. But why does Dalton's law are applied here? It's possible really because this is science. You can combine. Okay, it's possible that in one paragraph you will be asked of 1 million questions out of that. Get the point? So there's no such rule to limit the being asked. It's totally maximized, okay? So that's why if you want to become a scientist and an engineer, you have a wild imagination, critical thinking, okay? High analytical thinking. And then, of course, you have high ability of memorization. You get the point? For me, I go to the memorization because I don't have a very high intelligence quotient. IQ. I am only in the average, really, for sure. But of course, I have fluency in English communication and language because I love English subject so much. Okay, it reflects, right, the way I talked sometimes and the way I write articles and columns also. Okay, really, I write columns and articles when I was in high school and college in our publication school paper. And I joined editorial writing competition, sport writing competition. I made also my own poetry or poem in my first abroad when I went to Taiwan. Okay, so I am very young at the time. It's my first abroad. So I don't know how to mingle with other people. Okay, I don't know how to associate with them because I don't really, engage myself to any types of personalities. I cannot easily adopt for particular areas, okay, for their interests. Okay, so there's a conflict of interest sometimes. Okay, so it's better for me to be alone and to focus with myself. And then that's the time. Okay, for my first abroad, I was so very lonely because I'm very, very far from my family. Because if you're doing your first abroad, that is the most saddest thing in your life, and you cannot imagine the separation of the people whom you love around you. It's not very, very easy, right? Okay, so at that time, I kept on writing poems. I have my own poetry. I'll just say, until now, I saved it in my flash USB. So I composed a lot of poems. I also created and composed song, 2 songs lang siya. At least I composed 2 songs, right? Okay. And then, muna siya. Okay, reading, writing, like that, and researching. So, something like that, okay? So, I love really reading, okay? Reading talaga siya. And then, to be honest with you guys, even though nobody pushes me, I need to memorize terms. Even up to now. Really. If I see, for example, a term that I don't understand, I will memorize what the definition. Even though nobody pushes me to do that. I was not paid to do that. In my own only. Okay? So, meaning to say, I don't want to be stagnant. Something like that. I keep on moving in terms of learning and knowledge. To the people around me, to the environment I have now in my work, and also to the presence of online world. especially academic information, okay, like that, okay. And then I use also Google search, if I cannot understand. But sometimes Google search also displayed, you know, errors in their information sometimes only, not all the time, especially the Wikipedia, okay. So really, so disgusting sometimes, but not all the time, sometimes only. Okay, you have to be smart enough to double check. Okay, something like that. That information that you obtained from online world. Okay, going back to how to solve this problem. So the first step is to elucidate the given the data. Wow, elucidate talaga, June. Really. Mga terminologies kaayo, equivocal. Wow. Okay. I don't want to jeopardize you guys by listening in sometimes talking with profound terms and terminologies, meaning deep, okay, that is not commonly expressed in day-to-day lives, in your work, and you can only hear it sometimes in the newscasting, delivery of the news report, or in journalism in short, because there's a lot of vocabularies there, synonymous terms that we keep on changing that when we do the articles and columns in a certain publications called paper in your university, institution, and in your school. Okay? So I advise you, if you are really good in English, not really that good, shall we say average, above average, that you love to talk, to communicate, and then you can speak extemporaneously and verbatimly in the public, then you join journalism. Verbatimly. Wow. So spontaneous, ganon. Okay? Yung hindi siya pinagandaan, it will just come out in your brain cells what you're going to talk. Okay? So those are spontaneous delivery of speech and extemporaneous speaking. Okay? Like that. Okay, guys? And you can also join extemporaneous speaking contest if you want to. So, especially in our school before, in Cebu Institute of Technology, okay, that was an institution before. So, there's a lot of contests in English. In fact, I joined oratorical contest. My gosh, I was only third place. Oh. Wow. But I'm very, very proud that third place ko. Wow. My gosh, because there's a lot of departments in the college. College of Engineering and Architecture, Arts and Sciences, the Department of Accountancy and Commerce. And I should be thankful to God that I won third place, right? Get the point? Okay, I was not the winner in that particular contest, but I landed third place. Okay, oratorical contest. Now you can also join declamation contest if you want to. Okay, but I love extemporaneous speaking. Okay, for example, that contest really, guys, helps you to sharpen your mind and brain cells if they will give you a certain topic to be joined with. So, for example, topic drug addiction. Okay, like that. So, a lot of topics, right? And then you will be given 15 minutes to develop your content. Okay, and then after the 15 minutes preparation, on the spot, you will go to the stage and express what you understand for the topic. Okay, and you will try to express that, what you understand. You have to create your own content. And then the most important for that is the substance of your delivery of that speech. Okay, how really effective you capture the heart and the minds of the audience. That is really straightforward and not sugar-coated words. Okay, not sugar-coated meaning not superficial and shallow. Okay, you go directly to the point per point. It must have a sense. Okay, and it must teach you to be a good For example, to be a good leader in your society, okay, to be a good example in your community, something like that, or to encourage others also to take your part to become, an active leader to promote drug addiction, you know, prevention, something like that. Okay, anything. Okay, and then if you cannot understand really how to build up the content, it will start with the introduction, okay, content, okay, and the conclusion and the summary. So in your introduction, you need to express in a straightforward manner the topic generally. Okay? So in your introduction, you could understand very well. Okay? And then the content, you have to develop specific wise, meaning you have to elaborate, to explain some words and terms that are very, very essential to connect with your title, okay, in your introduction. Meaning your introduction shall connect to your content or your body of your content. And the last will be the summary or the conclusion. You need to summarize the overall, what you understand and share to the audience so that they can play an active role, okay, to promote that particular topic in their daily lives. Okay? For example, to help build helping hand in hand to solve this kind of problems like that, and we can build up a better future after all, something like that. Okay, so that's gonna be the basis for extemporaneous speaking. But the oratorical contest is more lengthy compared to extemporaneous speaking. The oratorical contest, you have to, to speak up what's on your mind, but again, following also the introduction, the content, and the summary. Okay, but here is another contest also, the declamation contest. This is different. This is unlimited. Okay, meaning to say, you don't have to organize your introduction, you don't have to organize your content. Okay, as long as you can express what's on your mind, but you have a very, very clear facial expression, the way you deliver your message with emotions or actions, just like a drama in the stage. This is the difference of declamation compared to the oratorical and extemporaneous speaking, because this is the time that you are having some props, if you want, props. Okay? You need to do actions. You have to kneel, you have to kick, you have to cry, okay, you have to shout. It depends on the content of your title or your subject. So there's no limitation. But you don't have to do that in extemporaneous speaking. Okay? Oratorical, you can do a little bit, but not too much. Okay? Because the focus is in the content. But for the declamation contest, both the actions, the gestures, and the stage presence of the communicator and how you convey your message with facial expression, dramatic expression that could help the audience to understand in your content of your declamation piece, something like that. Okay, so if you want to join this contest, then join. Okay, like that. So there are also contests in English that doesn't need to show you in the stage. For example, easy writing contest, like that, sports writing contest, okay, slogan making contest, editorial writing contest. And sometimes you have also to join that because it helps you to sharpen your minds, okay, how to create articles and columns, and this will be useful also in your reporting skills, especially in college. Okay, so you will never be afraid and you will volunteer, okay, the reporting if you have this kind of capabilities. Wow, capabilities. Okay, so you are very expressive and also a good communicator. A good communicator not necessarily straightforward all the time. Okay, a good communicator, it must also be detailed, organized, okay, and put too much creativity on how they deliver their content. Okay, because the more you are very, very straightforward also, and then the audience also will not be attracting to you because you have less emotion, less emotion, and then they don't get you because you did not express through your, physical attributes, your eyes, your hand, okay? Because these fingers, the eyes, the face, the mouth are very helpful also in order for them to get excited when you talk or when you communicate. Okay? Because sometimes also, if you are very straightforward and then you are standing only without using your hand, so it looks like boring. You got the point? Boring. But then if you are doing the gestures, facial expression, emotion, and you also inject a little bit of humor, like that, having some creativities in your delivery, then I think, not all, most of the audience will get interested in listening at you because you are not boring. Okay, meaning to say, it doesn't have always to be straightforward. Okay, the quality of a communicator. Okay, that's the main reason that any public speeches or whatever, it's lengthy. Lengthy, 1 hour, 2 hours, because of that reason. Okay? Or else, if you are straightforward, you can finish your speech in 10 seconds. You get the point? So if you are talking your content in 1 hour, then you are not straightforward already because it's very lengthy. Okay, you get the point? So meaning to say, a good communicator, not necessarily straightforward. Okay? To have that is also good, but what I mean, not necessarily. Okay? Because there are public speakers that are very creative, innovative, and then, apply gestures, actions, emotions, and intonation, the tone. For example, when I discuss, that's the intonation, so that it helps alert the students by your voice projection. The modulation of your voice also is very important. The loudness and the intensity of your voice is very important in order for them to understand also they hear it properly. Okay? To extract the content and the message of what you are trying to convey. Get the point? Something like that. So there are a lot of criteria, not only straightforward or simplified content. I'm talking to you like that. Ako yung gi-defend because that's my weakness also. My weakness really is I am very elaborative. When I talk, when I communicate, I am very detailed. I'm not going directly to the purpose or the objective of my content. Just like this, if I have this kind of vlogging, very lengthy, I could not manage to finish in 30 minutes, 35 minutes, because my mouth is keep on talking spontaneously. Okay, and I cannot control. Really, I cannot control what comes from my brain cells. And then I will try to talk with you. As long as it connects to the subject matter or the topic, and I have to connect that with you and discuss it with you also to make. Okay, going back to, diba, nitaas good siya. Uwing ani siya, diba? My topic is only distillation, but I keep on talking about other things, right? Oh, anyhow, that's me. Wow. Okay, going back to, because there's no time limit. For example, if I join also a declamation contest and a rhetorical contest and the time limit is only 30 minutes, then I have to do that also to be watchful of my time frame. Okay? But in here, there's no time limit. Okay? I have the full freedom to extend my vlogging and live streaming in front of you. Okay? And in fact, there's no time limit, so bingo, I can do what I want. Okay? And this is my personal vlogging, right? There's no control. Okay? Okay, as long as I can deliver my content. Okay? Something like that. Okay. First, required. Okay, required. Ganon. Required means what are being asked or what is being asked on the problem. So in here, guys, determine the mass flow rate. O, andyan naman tayo. Mass flow rate. Walang katapusang mass flow rate. This is very helpful in all engineering courses. Okay, I think except for industrial engineering, because they are not so much with material balances. They are more on the accountancy level. Accounting of financial aspects related. These accountancy related. I'm not really that sure if they have also this kind of material balances. Okay, but in all engineering, I felt that this course is not more on the sciences of all. Electrical engineering also is already a science because electricity is already a science. Mechanical engineering, mechanics or movement is already a science. So mechanical engineering. Electronics are already under science because that are composed of solids, substances, or metals. Okay, so electronics and communication also is under quantum mechanics, conveying the message through elementary particles. So electronics and communication engineering are basically science. Okay, like that. What else? Mining engineering, of course, that is pure science. They're talking about the minerals in the earth's crust and underground, the pure substances, the norm, naturally occurring radioactive materials. Study that also. So, science po siya. Mining engineering, metallurgical, samot. Those are sciences. And of course, BS chemical engineering. Okay, science talaga siya. Okay, but I don't think so with this industrial engineering, I'm not really sure. Charot. Okay? I think they are more on management engineering, this industrial engineering. I think so. Because most of them are becoming managers in the future who took up engineering. I'm not really that sure, because they have a very solid and rigid subject, which is the management engineering. Though we have also that subject, management, but their management is very rigid. Okay, rigid means very solid. Okay, like this. Okay, so mass flow rate. Guys, to tell you honestly, I remembered one time also when I was in third year. Okay, no, it's third year, second semester. Okay, so when I was in first year, second year, third year, first semester, and second semester, no, it's difficult for me to become a dance lister already. Okay, but when I was in first year, second year, third year, and then especially fourth year, first year, and fifth year, it's very difficult to be in the dense list category. Okay, because the subjects I keep on, very complicated already, and sometimes I cannot understand really now. Okay, and I cannot explain further. You know what I mean? Okay, if you are taking chemical engineering, you will feel that. Okay, so like this. Okay, so I think my last dance list in college, I think it's gonna be third year, second semester. Then fourth year up, I'm going down. Okay, but not really that down also. Okay, as long as your grade is not very low, right? And then it's not below 3 or 3.5 ba to siya or 3? I could not remember because our highest grade in CIT is 5, not 1. Okay, I think we have the same in Ateneo. Ateneo ba siya or LaSalle University? Only 2 schools in the entire Philippines that have 5 as the highest grade. 2. And CIT is one of them. I think it's LaSalle University, right? Or Ateneo? I'm not really sure. Okay? Ateneo University? Ano? LaSalle ba siya? I forgot! Basta duha ra jud ka buok. CIT o katong usa. Okay, 5 ang highest namo. Now kung naa kay 3.5, okay nya ubos sa 3.5, then you could not become a dance lister. Because the 3 would mean, I think that would mean 75% in our grading system. And then the 3.5 could mean 80%. Just like in high school, in elementary level, the 80% is the standard. Okay, if you have 80% up, right? If you experience this, if you are really also, okay, how can I call this? Because this is reality. I'm not arrogant, this is really reality. If you are also an achiever, academic achiever, you will also, feel that the 80% is the boundary, right? And below that one, if you have 79% grade in high school, elementary, okay, then you will not be in the honor student anymore. I remember that one because I'm also, a consistent honor student when I was in elementary and high school. Okay, so it's gonna be like that. So in our grading system in CIT, if you have three, it's very difficult for you to land in a dense list. Okay, this meaning honor students equivalent to the high school and the elementary, and then it's really difficult. But sometimes also I remember pala, okay, I was dense lister. I think it was fifth year, but I have three. I have lower, but nainat siya. Because the others are high, and it was pulled up. Since you have three, you will never go on the ranking. But if you try to average that one, it's also go high because the others are high. Right? You experience that one also if you have a very low. For example, out of 10 subjects, you have very low, right? And then if you average that one, it will pull up. Okay? Naka-experience kong ingon ni Ana. Gamay siya, and then nabitad siya. Pero dili na ka ma-dense list. Even though your average will go high. You got the point? Kini below naman gud siya sa 3.5. Ganun siya. Di jud matabang. Okay? Ganon. I think, paano to? Unit operation. Unit operation na to akong gamay kayo eh. Fairness. Charot. Lagi, murag kuan na siguro to, murag kuan, Unit 3, mga kuan, mas transfer na siguro to, na maglibog ko ba? Kaya itutuwad naman yung ka-exam na maglibog bang ko. Charot, okay. So, nigamay to akong grade, mo to ni us-us. And then, it will lower down. But still, murag, ka-averaging mo dako gyapon pero you will never advance list naman talaga pag may below something, right? You can relate if you are studying in CIT, right? But for other schools, their high grade is 1 man siya, so you could not relate. Something like that. Reverse grading system in other universities within Cebu. UC, like that, USJR, University of San Carlos. Okay, they have 1 as their highest grade. But for us, CIT, okay, 5. Our reason before, because it could never happen mathematically that 1 is greater than 5. That's the main reason of CIT people, why we choose 5 is our highest grade, because 5 is always greater than 1. Okay? It never be in mathematics that you can say 1 is greater than 5. You get the point? In mathematics, 5 is always greater than 1. So therefore, we conclude technically that 5 is our highest grade. You get the point? But other schools are basing on the usual, general understanding in a contest. Okay, for example, first place, second place, third place. Okay, if you are first place, your score will be 98. And if you're second place, your score will be 97. They're referring to a contest concept based their grading system. But our grading system is based on mathematical definition. That 5 is always greater than 1. That's why 5 is our grade, highest score, or highest grade in Cebu Institute of Technology University. Because our school also are home of engineers. Okay, so many top-notchers every year, something like that. Okay, it carries the excellence for that, Basta, you know what I mean. Okay, kung taga Cebu mo, you know what I mean. Okay? Okay, sari-sari lang mga top-notchers, whatever. Okay? So, mass flow rate, like that. Muna gitrain yun ang mga students sa CIT, first year pa lang, we have the motivation that our aim is to become a top-notcher. That's why also, the passers are high because you are trained, first year pa, pag tikang pang nimo sa CIT, we are cultured to that mentality. Okay? In CIT, mga tiknoy or technologian. So, though not all, but generally, we have that perspective that somewhere along the way, we need to be on the top, something like that, when we take the board examination. Okay, I'm not saying tanan, but you know, what do you call this one? The habitat, habitat, or the atmosphere of excellence engraved in the hearts and minds of the students in CIT when they started first year college of engineering, particularly. Okay, nanagid sa mga brain cells, sa mga majority of the engineering students in CIT, that we should be on the top. Okay, like that. That's why most of our instructors most of them are top-notchers also. A lot. Okay, patan mo top sila, and they are also our instructors like that. Okay, you get the point. Okay, so mass flow rate. Okay, ganun siya. It doesn't mean nga mo naging ani ko because I have YT channel by yun. It's not related to, you know, to the tradition of excellence of CIT, ha. This is my personal choice to have YT, and I have to explain, man, okay? So it doesn't, oh my gosh, you know what I mean, okay? So determine hambog ka siya, no, it's not. It's really true. Before I speak, I must, what do you call the one? I must connect it with reality. Okay, so determine the mass flow rate of the overhead product or bottom product. So muna na siya, guys. Mass flow rate siya sa bottom product, meaning to say, this is really the condensate. Mass flow rate of the bottom product is the condensate, right? Okay? Ganun siya. Okay? Bottom product, yung kayo. Wow. Asa na ako mga kwan, may mga pentel pen, whatever, chuchu, wala din siya, guys. Okay. Number 2, the mass, okay. The overhead product also, the distillate. The mass flow rate of the distillate or the mass flow rate of the overhead product. Okay. Something like that. The mass flow rate of the overhead product. Okay. Overhead. Okay. Product. With D, product. Okay. So that's pronunciation. Talaga, may pronunciation. Nakakaloka. Okay. Mass fraction of benzene at the bottom product. Wow. Mass fraction of benzene. Hello? Benzene is aromatic hydrocarbon. You remember the difference between aliphatic hydrocarbon and aromatic hydrocarbon in organic chemistry, right? Okay, shout out to all chemical engineering all over the world, right? Aliphatic and the difference between an aliphatic hydrocarbon versus aromatic hydrocarbon. So if we have the benzene ring, that is usually aromatic, right? Then the aliphatic without benzene ring. Correct me if I'm wrong, huh? Okay? Because there's two types. Okay, the aliphatic hydrocarbon and the aromatic hydrocarbon. It means aromatic because when you break down the bands, the intermolecular bands of that particular hydrocarbon, it will create a smell, like an aroma. Okay? That's why it's called aromatic hydrocarbon. Because when you apply heat at higher temperature, the intermolecular forces in the molecules of this organic compound or organic compound will split and it will produce a gas phase or a vapor that is very having a good smell, good aroma. That's why aromatic hydrocarbon. Okay? Mass fraction of benzene. Smell man siya, aroma, right? Okay? Mass fraction of benzene. Of the bottom product, oh my gosh, mass fraction of benzene in the condensate. My goodness. Okay. And then are the required guys? 3. Gosh. 3 are being asked in this particular problem. Okay? Now, what are the data? The data is simply the given, or the information you extract out from the problem, or you obtain out of the problem. Okay? Data. So, a liquid mixture meaning there are 2 or more substances involved, a minimum of 2 if we speak about mixture. Not necessarily they are dissolving with each other, as long as they are combined with each other. That's still mixture, just like oil and water. Okay, the oil will goes up and the water will go down, something like that. Okay, because water is more dense compared to oil. It matters on the density of those substances. When we speak about the surface layer of the mixture, density matters there. Okay? So going back. Liquid mixture. If we have the mixture, we have the solution. The difference between the solution and the mixture, because the solution, it has to do something with the solubility, meaning it will really dissolve. Okay? The liquid shall dissolve to the solid. The solid will dissolve also to the liquid. So vice versa. But not through to mixture. Because mixture, you have only to combine that one, not necessarily to dissolve with each other. Okay, that's the difference. Maybe the question in the future, differentiate between a mixture and a solution. Ganon. So say, by your own statement lang siya. Okay, then that is what it means. Okay, you can have your own terms and words. Basta imong timan-an, mixture can only be combined and mixed, but not necessarily to dissolve with each other. Okay? So this solution is always dissolving with each other, the solute and the solvent. Okay? Or else, if they will not dissolve with each other, it's still a mixture. Okay? Because mixture is referring to the, what do you call this one? Miscibility and immiscibility. Wow. And the solution are basing on the solubility. How insoluble and how soluble. Because immiscibility and miscibility doesn't refer to the concentration. It refers only to the layer, surface layer of those substances. But when you talk about solubility, it refers to how it dissolves one substance over the other. Insoluble and soluble, meaning solubility. So this is a solution, not a mixture. You get the point? Okay? Now the mixture is basing only to the miscibility and immiscibility, the surface layers. Okay? Not necessarily the concentrations. But sometimes also the mixture can do what solution do, but I'm referring only to the technical definition. Okay? Because sometimes also have. Okay, but rare lang siya. For example, if I will mix the laptop and the water, it is a solution? It is not, because the laptop will not dissolve to water. Okay? And laptop is a solid and water is a liquid, so heterogeneous mixture. Okay? If liquid and liquid will be mixed in a mixture, that is homogeneous mixture. If the phase involved in the particular combination of one substance over the other that is heterogeneous, different. Okay? Like that. So I think you can understand what I'm referring to. Another also, the hydrophobic and hydrophilic is another term also. Okay, if hydrophobic, meaning it will not dissolve to water. Our basis is water. If it is hydrophilic, it will dissolve to water. Okay, most of the fats inside our body, the cholesterol, okay, the density, lipoprotein, like the DNA, okay, synthesis in our body, the steroids, hormones like that, most of them are hydrophobic. They will never dissolve to water. Okay? Except to inorganic substances inside our body that is hydrophilic. They have high affinity and the ability to combine or react with water. That's why it will be dissolved with water and to be washed out from our system during urination, urine, bowel movement, something like that. Vowel pala, dili bowel. Okay, ang bowel katuman ng mga O-U-I-E-E, right? Ang vowel, V-O-W-E-L, mamana siya ang katong stool. S-T-O-O-L, or the, what do you call this one? Fecal, F-A-C-A-L. There's a lot of terms, and also, we call that also a manure. M-A-N-U-R-E. Human manure, human waste, stool, fecal, and vowel are synonymous with each other. Right? In medical term, we will use the stool in the test to determine whether we have our digestive tract or digestive system are no longer functioning very well. That's why we have the test to remove, or bacteria present in our digestive tract or digestive system. That's why we need to have the stool test in the medical examination. But what I mean, stool have different names. Again, stool is the same as fecal, F-A-C-A-L. It's also the same with human manure and human waste. Okay? Dito po. And vowel, V-O-W-E-L. Not the vowel katong ko. Asa may vowel or vowel? Murag kuan siya, bali. My gosh, naglibog na ako. Ang kuan pala, ang vowel pala, B-O-W-E-L mo na siya ang tai. Ang vowel, mo to katong A-E-I-O-O. Mo na siya no, vowel, V-O-W-E-L. May mga English major, correct me if I'm wrong. Murag nabalagtad ang akong understanding. Wow. A-E-I-O-O. Okay, those are vowel. Okay, vowels, V-O-W-E na bali, V-O-W-E-L. And then consonants, kato mga Q-R-S-T-U-V-W, consonants. Okay? And then, vowel pala siya, B-O-W-E-L, ang stool, ang fecal, ang human waste, or ang human manure. 5 terms can be used interchangeably. The same meaning. Okay? So, because sometimes the stool will be replaced with another term and you couldn't understand anymore. For example, calculate the percentage by mass of a fecal matter after sampling that in the laboratory. Calculate the mass flow rate of fecal. Wala nakakabaw. Pero ang fecal, more na siya ang tahi. Okay? So, you get a sample of the stool because stool is just the same with fecal. You-change ra ang term ba? Okay? Sometimes magunay mangyayari ang mga problem. Mo use of terms that are not very common to the majority. Something like that. Okay? So, pero the common is stool siya, stool test or stool examination when we do our medical examination or like that in the doctor, right? For the laboratory test. Okay, data. Okay. 45% benzene and 55% toluene by mass. It's very clear by mass, meaning mass fraction. Okay? Now, so we will have the basis of calculation later on. Di ba ningon ko ninyo na we have a basis of calculation? It's not all the time 100. Okay, why? Because the basis of calculation on 100 is always good if there's no given feed. Okay? If there's no given already the feed amount. If there's a feed amount that you will try to put that in your inlet before going to the outlet, then you don't have to have the basis of calculation ng 100. Kana siya, kung wag siya given na feed, mo na mag-100 yun ka. You get the point? But kung naa, ayaw pag sa 100, kinama kay given. Okay? So, ganun siya. So, 45% of benzene. Oh, ganon. Oh my gosh. Tabi ay si June. Okay, guys. Are you still there? Mga kapatid, kapuso, kapamilya, kaber, kajowa, kasosyo, kaaway. Okay? So, 45% benzene. Guys, this is very helpful also if you want to create your own chemical product to have a business also. You will do separation processes also and calculating all the mass percentages of your raw material. Since you are the chemical engineer, then you know how to do it, right? Especially if it involves only mixing. Mixing, very easy to, and a little bit of, filtration. You get the filter paper, right? And then you put it in the funnel, F-U-N-N-E-L, and put that in the graduated cylinder to separate the liquid from solid, something like that. And then you will produce only, for example, 20 pieces or 20 units of your product, like that. And then later on, you will expand your business. It's just only experimental for the very, very first time. And then if it's really effective to do that, then you can have your business in a large scale. Okay? First, start with a small scale business that you can manage easily for the very first time as your experimental basis of doing the business. And then after that, if, oh my gosh, this is really very effective, and then do it in a large scale, you expand your business like that. Then what I'm trying to say, if your product really are chemicals, then this will be helpful. Okay, because these are all chemicals. Okay, you get the point? For example, if I will make a soap business, S-O-A-P, this is about soap business. The other one, or detergent, for example, I will make my own. I am a chemist and I am a chemical engineer. I know how to do that, right? So I have the proper and adequate equipment and technology to do that. Then bingo, I can do that, right? Because the limitation only is for the equipment. Equipment costs a lot, manggod siya. Then if you start with a small business producing a chemical product, there are also chemical products that cannot be obtained through simple mixing. That's why you need to buy this equipment. That's why nobody dares also to make their own chemical product, because usually at a minimum level, it will use a lot of apparatus. You should buy the beaker, you should buy this container, the flask, the titration equipment, ganon. Okay? And a lot. The gravimetric equipment, your gravimetric analysis, or your spectrophotometer and chromatography analysis also. Okay? Determination of concentration through the presence of light ray. Okay? And the polarity of the substance, chromatography, right? And then there's a lot of, a lot of technique in, quantitative chemistry and qualitative chemistry, or the analytical chemistry. Analytical chemistry composed of qualitative chemistry and quantitative chemistry. These are the two types of analytical chemistry. Okay? It needs you to analyze quantitatively and qualitatively. Okay, quantitatively meaning measuring the amount. Qualitatively meaning determining what's the substance. Okay, that's why in that subjects, in the qualitative chemistry, your instructors will give you a substance that you will never know, and you will identify that later on by having different methods and techniques or a procedure. But the quantitative chemistry, you are given this sample and you know that in the first place, then you have to determine the amounts present in that particular mixture or solution by having different techniques and methods of laboratory analysis. Okay? Get the point? But today, mostly are high technology na siya, so you don't have to do the conventional and traditional way of measuring or expressing the concentrations, right? You need to, put that in a computer, blah, 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 and here goes, bingo, it will show on the screen, the graph, the values, like that, okay? So, before, very difficult because we need to do it manually, okay? You get the point? Katong magtutuyok na parang pindulong, ay kalisod. So, imo yung i-balance. Charot! Okay, so 45% benzene. Okay? 55% of toluene. Minumdum yung ko ato ay, grabe kayo. Charot. Instructor ba kayo mong maestra? Grabe yung kayo. By mas, kaloka? Is feed to a distillation column. Okay. Product stream leaving in the top of the column. This is the overhead product, of course, the distillate, right? Okay. And then contains 95 mole percent of B at the bottom product. Laoy. So, mo ni siya ang feed F. Ang bottom product, 95 mole percent. So, kuha yun siya ay. Sige na lang. So, 95 mole percent. Okay. Benzene. Okay. In your bottom. Now guys, in your bottom guys, expressed in mole percent. And it's not compatible with the feed, which is the mass percent. So there's a lot of conversion will be happening here. Okay, from mole to mass or mass to mole. But it would be rather helpful. It would be rather more good to convert this mole percent to mass fraction because your required quantities here are mass flow rate. It's not molecular flow rate or it's not volumetric flow rate. Okay? What I mean of molecular flow rate is just mole over left second. Mole per second, mole per hour, that is molecular flow rate or molar flow rate. Wa ko nag-create og ako ra ha, I base that in the science talaga. If we have the mole, we have also the mass. If you have the volume, so this is not used all the time. We know that, but this exists. Okay, so mole per second, mole per hour is the molar flow rate or molecular flow rate. Okay, and then we have also volumetric, meaning volume over the hours, seconds, and mass flow rate over mass. But common kayo sa atong subject, ang mass, ang volumetric. Then, what I'm trying to emphasize, what if the question in the future examination will ask you for the molar flow rate? In which we are not used to for that. Because our examples in different subjects in engineering, especially chemical engineering, are more on the volumetric flow rate, mass flow rate. It will never touch the mole flow rate, also on the density flow rate. Density flow rate also is possible. Okay? Just put in that in the numerator and put moles in the denominator, and you can also play around the unit, and that is already density flow rate. It's not common, but technically it will exist also. Okay? So kung naay nga na ang mga mass ug ang volume, this possibly sagnay may nga na ang ubang quantity. Okay? Because density, mass, and volume is in the equation already. So magpaalakan sa kasi density. You get the point? If you have density is equals to mass over volume and mass flow rate, volumetric flow rate, how about the density? Magpaalakan siya? So it's not. So it's also possible there is density flow rate. Got the point? It's not common though, but we don't know really. Okay, in future examinations, because expect the unexpected by a good shot. Okay, like that. And then we have also molecular flow rate or mole flow rate, though it was not also discussed very well, because the common only, more gini pirmi ang ginakuha sa engineering kaning mass flow rate, volumetric. What I'm trying to say, you should maximize. Okay, maximize your learning, not only to the very common, terms, so that you can easily pass certain examinations in the future. Okay, that's gonna be the mentality of all examinees all over the world. Okay, ganon. You get the point? In that way, really, you will pass. Because you're looking for the, the maximum, maximum tendency, maximum possibility that will happen. Not limited ba siya? Okay? For example, like there are 1,000 formulas and equations in chemical engineering. Okay? Imong pasubraan. Himo-himoong 2,000 equations. Okay? Subraan mo ang normal ba para manggawas tong mga wa dito sa 1,000 na imong gi-memorize, maka-answer gihapon ka. Di na ka magpakli-pakli sa Paris Chemical Engineer's Handbook or whatever references you're using in the actual examination in the future. Ang ganon. Di ba? So, ganon ang mga technique. Okay, guys? Strategy ba? Strategy. Okay. Ayaw dyan ko sa minimum ha. At huwag yung promise sa maximum. Oh. Na ako dyan ang number 1. Ganun. Though feeling rago na siya, guys, it doesn't have it to be wrong when you have that feeling. Who cares? You have only that feeling. Okay? So, that's a good motivation for you to inspire yourself to be on the top. Though it's impossible, but who knows? You can really be on the top. So that's positivism. Okay? Most of the positive people will have high or great result, achieve or yield great results. Okay? So, high, bottom, middle. So your perspective or target should be on the high. Okay? Maximum. So that you will yield on the top, not on the average, not on the bottom. So, ano na siya diba? Positive mentality. That would help you a lot. Okay, though it's impossible sometimes, right? But we need to have that perspective in our mind. If all people have that perspective, then all will pass certain examinations, right? Or else, walang jud ka nagtuon, whatever. Ganon siya. Okay? Ganon siya. 80% to 90% kakugi. Okay? Kugihan kay ka magkuan-kuan, di ba? Kuan-kuan jud. Okay? So, 95% benzene, going back to the problem. Okay? Nalingaw na ako chika-chika ninyo, guys. Okay. And then, kung 95 mole percent ang benzene, ang sati pare sa benzene niya in our mixture, in the feed is the toluene, then the 5 mole percent will be automatically the toluene. Okay? Because there are binary. You know binary mixture? 2. Binary. Okay? It happens here, there's a benzene and there's also a toluene. Okay? Like that. So, the benzene has its vapor state and has its liquid state, and the toluene also has its vapor state and has its liquid state. Now, the benzene has its vapor state and the toluene has also its vapor state. The vapor state in benzene will be added to the vapor state of toluene because they are in equilibrium with each other. That's why in the Machiavellian method, we have the equilibrium line. That's the purpose, or else they will not meet each other somewhere along the way. Okay? So, the liquid state of the toluene plus the liquid state of the benzene will be mixed together again because they are in equilibrium with each other. That's why we have the equilibrium line. Okay? That's why we plot one by one the liquid and the vapor, the liquid and the vapor, the liquid and the vapor, the liquid and the vapor. Okay. It's common in this binary mixture that we need to consider the lighter. Between toluene and benzene class, this is basics only, ha? It's not part of the, complexity of the problem. Okay? In this mixture, guys, you need also to troubleshoot which is lighter, the benzene or the toluene. Because in your distillation column, usually, the one who will escape, not escape, the one who goes up directly are it could be toluene vapor or benzene vapor. Okay? Because the vapor of benzene and the vapor of toluene is not the same molecular weight. Okay? It's different. Okay? Because it's coming from toluene, it's coming from benzene. Do not expect that they have the same qualities. Okay? Quality meaning percentage. That's why we have Q line, that is quality, if it is a saturated liquid or saturated vapor, in its saturation point. Saturation point meaning lowest temperature when it will be in equilibrium stage over the other. That is saturation point. Okay? Like that. Okay. Now, what we will do now in that manner. Okay? So actually, dagan kayo siya kuti-kuti. Na-vapor ang tuluin, nasa siya liquid ang kuan, ang tuluin. What is good, when you say bottom product, vapor siya. Vapor lang yun siya sa tuluin. Ang vapor sa benzene, nasagol na siya. Okay? And then sa taas ko, distillate po sa tuluin, and distillate po sa kuan, sa katong benzene, nasagol na siya. Okay. But what vaporize more easily is the benzene. It derived from its molar mass and molecular weight. Okay. Gaan ang benzene compared to toluene. The molecular weight of toluene is 92.14 grams per mole, and the molecular weight or the molar mass of the benzene is 78 point something, nakalimot ko, 78.408. Okay? So, molecular weight less, dali ka siya musaka because it's lighter over the other. So, meaning to say, that's why here, we will always compute on the benzene side, not on the toluene side. But if the problem will still ask for the toluene, so then compute the same as what you did in the benzene. Okay? But you can also compute that one because, in the mole fraction, the mole of the other will be computed. So there's no escape. You get the point? Mole percent. Mole of a solute over the mole of the solution. Now, if the problem requires you to compute with the moles of the benzene, now mole of the benzene over mole of the benzene plus mole of the toluene. Then, if you're trying to ask for the mole of the toluene, so ang mole of the toluene in the numerator over the mole of the solution. So there's no escape. You have to troubleshoot and to obtain also the molar mass of toluene, the same as what you did in benzene. You get the point? Something like that. Oh my gosh, nakakaloka. Daghang tabi. Daghang tabi kaysa solve, no? Mo jud. Haloka. Okay, di man ko bright of math. Okay, let's go back. So 95 mole percent of benzene. O muna na siya. And then, a bottom product stream, ako lang yung siyang sabton. Okay? I will never think that I am not good in mathematics as my barrier to understand the problem. I always think that I will go to the formal way of analyzing and understanding the problem. Even though I'm not good in mathematics, then it will help me a lot also. Positivism, as I told you. Positivism. To have a positive mind. Okay, that you can solve complex problems. Just like in our personal life, you can solve complex problems, then it's easy for us to live happily. Okay? Just like that. Okay? Have that attitude and character. Okay? Okay. As a student, as an examinee, okay? My gosh. So again, 8% mass fraction of the benzene. Oh my gosh. So 8%. Kaluka, uy. So, amin ako pag-express. Wow, express talaga. Mustap ko niya, mag-second version na yun. Oh, second segment. 8%. Magtaas na kayo siya. 8%. Charot. Hoy? Ano nangyari, John? 8%. Lah. Hurot ang mga pintel pen. Uy, nakakaloka. Sorry guys. Makita niyo ang ball pen? May kasuwat na ako. If I write in ball pen, can you read it clearly? So that you can comprehend during my discussion or not? So if I will write this in a pentel pen, then my pentel pen ink almost consumed. So it's not really visible enough to your eyes. Okay, so 8%. Charat. 8% by mass of benzene. Charot. Mass. Okay, benzene ha. Guys, so kung na-8% mass percent of benzene, then the other 92% mass, percentage by mass, is from the toluene. Okay? Like that. Kay binary naman siya, binary mixture. Okay? Okay, ganun siya. And then, okay na, magsugod na ta. Now, we are now in the number 3. What are the appropriate equations to be used? Okay, first, we don't need the y-intercept, the slope of the rectifying line, the slope of the stripping line, or anything chuva-chuchu or the feed line. We don't need that because we are not asked by the number of trays to be computed, number of stages to be computed, or the number of plates of your distillation column. Okay, so this is more on the balancing of your materials that will goes in and that will goes out, or shall we say the feed and the product, the inlet and the outlet, the input and the output. Okay, like that. So the entry and the exit, those looks like similarities, right? The entry, the entrance and the exit, the inlet and the outlet, the initial and the final. Okay, something like the feed and the product. Okay, the raw material and the product, something like that. The feed, okay, what's in. So there's a lot of terms to be interchanged, ha? Sa mga inlet, sa mga outlet, ganun. So it depends on the problem. Okay? Ang pare sa feed is always product, right? Ang pare sa inlet is always outlet. Ang pare sa initial always final. Okay, ang pare sa sa entrance always exit. Okay? You get the point? Okay, but raw material also ang pares product. Okay? Ganun. Okay, so muna yung overall material balance. So we need to draw equations man no, di ba itong ipangita? So we need to draw na so that we can have our equations and formulas. So this is the distillation column. Guys, a distillation column is vertical, vertical position. Or else, if it is an horizontal position, that is not a distillation column. You get the point? The design of a distillation column is vertical position, not horizontal. If it is horizontal, that could only be the reflux drum, okay, or any drums, a container only to hold temporarily the liquids like that before it will go out to another pipeline, something like that. Okay. Okay. Or the purpose only is to collect temporarily there. And then then it will go to another connection in the elbow, in the T connection. Okay, it's gonna be like the series of connection of the pipelines where the solids and liquids mixture will go, or liquid mixture will go, or only liquid will go, only solid will go. It depends on the situation of your physical and chemical processes in your industries, something like that. Okay, so this is distillation column or distillation unit. Okay. Ganon. So, ang feed, diri-ari. Okay, feed. Okay. And then we will put the condenser here. The condenser is where the condensation is happening. Okay. Again, condensation, we need to what? What's the definition of a condensation? A change from gas to liquids. So we need to condense the vapor into liquid so that we have the distillate. Okay? So the condensation took place at the upper portion and the heating took place in the bottom portion. The bottom portion involves reboiler and the top portion involves condenser and the reflux drum. Okay, and then there's a pump in the reboiler, motor pump in the reboiler. There's also a motor pump in the upper side. So we are not concentrated and focused on the energy that the pump delivers. Okay? We are focusing what's inside the distillation unit. Okay? We don't need to, 1 horsepower is equal to 746 watts. And that's the power of our motor pump to deliver this liquid to go to the distillation. We don't concern for that. Okay, we are concerned what's inside, what's going on. Okay, in going out and in going outside, in going in, like, okay, the streams. That's what we call streams. streams. The liquid stream and the vapor stream. Okay, the bottom product stream or the overhead product stream, or sometimes it will always be like this: overhead stream or bottom stream. That could mean distillate and your condensate. Okay, ilis na naman ko nilang terms. Okay, during the the paragraph of the problem na makaloka o sa extract ra gani usahay. Okay, the extract in the upper portion is like this, and that extract is the distillate. If you understand, that is in the upper. Okay, but that word extract is not usually involved in distillation. That's only for extraction process. Extraction is another separation process based on the solubility of the liquids. Concentration na siya. Ang pinag-usapan sa extraction. Okay, but in distillation, we don't focus yet for the concentration, ha? We are focusing for the flow streams, ganon-ganon. Sa vapor and liquid lang yun siya. Though you considering the compositions on the component balance, but that is not the center. But for the extraction, you need to troubleshoot the concentration. Okay? Because it is a separation process used to separate, okay, liquids to liquids, gas to liquids based, okay, on the solubility or concentration. Muna siya ang extraction. But here is distillation. Okay? So ang bida, an actor of this topic is the distillate. That's why distillation. Okay? Siya dyan ang nag-carry sa name. Just like Philippine Airlines. They are carrying the name of the Philippines. Okay, that's Philippine Airlines. So, most siya ang distillation. Ang distillate, ang ni-carry sa name, sa process. So, distillation because of the word distillate. Okay? Like that. So, ang distillate na to, guys, kay D. Okay? Ang bottom na to is, ato lang ibutang W, kay mo may gibutang sa mga libro. Okay? But actually, I love to put B, the first letter of the term. But, ato lang yung tumanon ang nasa libro. W lang. Okay? Because W is water, right? Kaloka. So, B na lang. Oh no, W. Okay. Naanod ko sa W. Charot! Okay. Moni siyang nahitabo karong higayon na. Okay? So, the feed will goes in, and the distillate and the condensate will goes out. So, by simple mathematics, overall material balance, what goes in is the feed, and what goes out are the distillate and the condensate. So, T plus W. Okay? And this will be our equation number 1. Okay? Overall material balance. Okay? And now after that overall material balance, we have also, guys, the component. Now kayo, guys, have to off the air condition. Gosh, it's very cold. I cannot sustain to the lower level of temperature at this point in time. I have to off the AC. Okay, very cold really, because it's October, and after that 2 months, December is very cold already, right? So I have to off the AC for a while. Okay, like that. So the overall material balance is the feed equal to the distillate or the condensate, or we can say that feed mixture, or shall we say liquid mixture, is equal to the overhead product plus the bottom product, something like that. Or you can say simply vapor plus the liquid, anyhow, to make it simpler, right? Bisag to duwaro na siya, nakasabot lang jud ka, mo na siya ang define. Okay? So for the component balance. Component, guys, meaning concentration expressed could either be mole percent, mass fraction, volume by mass. Volume percentage, mass percentage, mole percentage, pressure percentage. That's why we have also pressure fraction. Okay? Then molar. The mole, right? That's molar, right? So, ganun siya. Okay? So, this is component. Or shall we say the concentration. Okay? Then if you put percent, a small percent, blah, blah, blah. So, ganon. So, F times, let's just put this as, Z, zebra, for the component or the, the mole fraction or fraction of the feed mixture. So let's put this Z, small letter Z, okay? It's up to you what you put as long as you understand that this is going to be the component or the mole fraction or mass fraction of your feed. Okay, so distillate times, let's put XD, the common one, since we are in college, like that, or in high school. We don't have distillation in high school, right? It's a little bit complex now already. Okay, so W times XW, meaning the bottom product times the component or the concentration of the bottom product or the condensate. Okay? Ganun siya. So equation number 2. Okay, let's investigate now if these quantities involved in equation number 1 and equation number 2 are present so that we can easily substitute directly to make our equation simplified. Okay, it helps us to reduce the complexity of our solution. Okay, and how to solve the problem. Okay, so it's gonna be like this. You get the point, class? Okay. Okay. In this manner, you have to tuki, meaning you have to scrutinize, examine, or visually check, something like that, the quantity per quantity, something like that, okay? So, okay, that's 1 and 2, and we have that already. Okay, now, oh my gosh, so what is the value of Z? Here, guys, we have the feed mixture of benzene and toluene, a binary mixture, right? So as I told you a while ago, we are not concentrated on the solubility. We are concentrating only to the basing on the boiling points. Lighter over the other, so that the vapor will goes up, the liquid will go down. So basing only by their boiling points. Because this is the definition of distillation. It is a separation process based on the difference of the boiling points of the vapor and the liquid. Okay, that's very clear. Now, 45% of the benzene. So benzene, we let this benzene is our A, like that. So I must put here FZA because we are solving for benzene. You got a point? If we're solving for toluene also, we can say FZB. Okay, because there are two components here, A and B. Okay, you get the point? Like that. Since we are not yet, we are not focused on the toluene. We are focusing on the benzene. What's the reason, Gane, why we are focusing to the benzene? Because benzene is lighter than toluene. Okay? Most of the vapor of the benzene will goes up easily. And the more will be easily condensed to liquid over the toluene. But this toluene also vapor will be also condensed. What I'm trying to say, it's less compared to this benzene. Lighter magud siya. Okay, so the more molecular weight, the lesser molecular weight, lighter siya. More molecular weight, heavier siya. Okay, that's why ato siya sa bottom. Okay, bugat man siya. Okay? Like that. Ang bugat nga, basa nga papel, bugat siya compared to the dry paper. It's gonna be the logic like that. Okay? That's why we wash our clothes. Okay? If you try to weigh both the wet clothes and the dry clothes, of course, the wet clothes is very massive. Okay? Very weightful. Bugat. Heavy. Something like that. Okay? Kinaman siya moisture. Wet man siya. Okay? Whereas compared to the dry, wala naman siya liquid. Okay, that's drying. It's also another process of separation technique in unit operation. Drying. Ang sa may definition na ng drying. Drying is a separation technique or separation process that used to separate the solid from the liquid. Okay, so the liquid will be removed from the solid through vaporization or evaporation. Okay? So meaning to say, it involves solid and liquid like that, or liquid-liquid, pwede sad siya. Okay? But in most cases, solid and liquid yun siya. Okay? Kay solid man ang solid ang dress, mga clothes are solid. And then liquid ang water. So it's solid and liquid, right? After removal of the liquid, what remains are the dress and the clothes. And if we apply that to the chemical substance, it's the same story. Okay, the removal of liquid from the solid substance through evaporation and vaporization. Okay, very clear. Okay, that's drying. That's another separation technique. We go that later also. After, there's a lot. I think there's 20 physical and chemical separation process. I'll go to this chemical and separation process that involves overall material balance, component balance, and have so many formulas because others also don't have formulas. Okay? For example, we have the process of flocculation. Okay, the process of flocculation in chemical engineering or in science is a removal of, solid from liquid in a coagulate, in a coagulation. Charot. Or in a colloid substance. Lawin abot ng colloid. Sabi ng colloid, sir? Wow. So, di na ito mabalik ang colloid. You know what I mean about that? Okay? So, when we mean of colloid, na siya mukhaan siya coagulate ba? Na, di ba mo pass ang light? If you have a beaker and a liquid solvent or a chemical solvent and you pass that by the light ray, okay, something like that, there's a Brownian movement of the ray in chemistry. I think so. Brownian movement. And then there's developed a Tyndall effect. If you remember your science in elementary level of education, there's a Tyndall effect. Grade 6 or grade 5, it was taught by our teachers. This is only stock knowledge. Okay, there's a Tyndall effect. Okay, and then there's a Brownian movement of the molecules. And after that one, it will produce a lump of crystal or solid substance and it will coagulate. Okay, so the coagulation process produces a precipitate. Okay, so that's what we mean by colloid. Okay, meaning solid substance chuva-chuchu. If we mean about precipitate, coagulate. So the process there is precipitation or coagulation. But the product produced is the colloid. Okay, that's why the definition of this flocculation. Wow. Flocculation meaning FLOCCULATIO. It is also a separation process in unit operation, but doesn't involve so many formulas. Sa'yo na kasi ikon-kuan ba? Okay, so this is the removal of solid from liquid in a colloid. Ganun. So going back, so i-maximize po nato ang mga separation processes ha. Di lang mo limit sa katong mga common na kayo nga mga kuan lang siya, distillation, crystallization, filtration na nasa mga unit mo extend kita sa mga uban nga dili kay common katong mga electrophoresis. Okay, part man gyapon na siya sa chemical engineering. Katong mga chromatography, okay, spectrophotometry process, okay. Ato jung i-maximize. We will maximize our knowledge and learning for all chemical separation processes in science or in chemical engineering or in BS chemistry curriculum. Okay? Di na to siya ilimit sa katong mga common lang yun. Okay? Mo extend yun ta kay expect the unexpected man yun ang future examinations. Okay? Muna siya metabo. So if you really want to become a top-notcher. Okay? Ato dito sa maximum so that kung para di ka matagak, so mo aim dito top-notcher. Okay? So muna siya naitabo. Okay, now, going back here, so D times XD. Now, D is a distillate capital D. And we have also XD. Wow, bongacious. XD is our mole fraction of our distillate. Benzene. Okay? It's here, right? Diba? Then, XW, mole fraction of the bottom product or the condensate. Okay? And W is our bottom product. Okay. Muna na siya. Nangasa pa yung mga data nga mo, help na to ani. Okay. So, okay. The volumetric flow rate, nasa taani, kakaloka. Walang katapusang volumetric flow rate from general chemistry lecture. Okay. Go to the higher subjects in chemical engineering. Still, it will appear over and over again. Okay? Even though in high school, there's already a volumetric flow rate. I remember that one in chemistry. Okay? Because I love chemistry, that's why. Okay. So, volumetric flow rate, if you don't love something, and it will never return to your brain cells. Okay? It will never stuck to to your brain if you don't love the topics or subjects or anything that you don't love. It will never retain. Okay? It will never engraved in your heart and in your mind if you don't love for that particular topic or anything that you don't love or you have no interest at all. It will never be remembered. You get the point? But then, if you love that thing, it will really stuck to your brain cells, your heart, and in your mind because you love that things. Okay? It's gonna be like that. Okay? In anything. Okay? Because it is not purely memorization that matters. Okay? You should understand what you memorized. Okay? Going back here, so we have now the 2,000 letter per hour. Laoy, kakaloka. 2,000 letter per hour, we need to distinguish this. This is the volumetric flow rate. When we mean of rate, R-A-T-E, there's always time in the denominator. Remember that one, ha? Anything. Rate na siya talaga. Okay? If there's hours, seconds, years, mass in the denominator, so that is already a rate. Okay? Or second. And then the numerator is capital L. So this is liter. Andiyan na naman tayo. 1 liter is equals to 1,000 milliliter. 1 liter is equals to 1,000 cubic centimeter. Ganun. Convert na po mo siya decimeter, cubic decimeter, cubic centimeter, cubic meter, gallon, because gallon also is a volume. Okay. 1 gallon is equals to 3.785 liters. Get the point? Like that. Muna siya permi ang mag-convert ka ni anang higayuna. Okay? Then, 2.2 pound is equals to 1 kilogram. Okay? 1 pound is equals to 454 grams. Those conversion factors are very useful in your quantitative computation of measurements in science and chemistry, physics, or whatever. Okay? It's very helpful. Okay? The basic conversion factors. What I mean, 1 feet is equals to 0.3048 meter. 1 meter is equals to 3.28 feet. Ganon. Mga ganon siyang chuba-chucho. Okay? 1 centimeter, how many inches? 1 inch is equals to 2.54 centimeter. 1 meter is equals to 100 centimeter. Ganon, chuba-chucho. You have to memorize that all. Bakit sinabi kong all? Because common. Okay? Okay, like that. Ano lang ito mga 1 quart is equals to 3 pint. P-I-N-T. I remember that in high school also. I memorized that. 1 quart is equals to 3 pint. P-I-N-T. Okay? So mga measurements siya ba? Di ba? When you buy the notebook, when you're in elementary, instead of looking the actors and actresses in the first cover, me reverse. I will go to the conversion factors at the back of the notebook. Really. And I will go to the multiplication table. I will never look to the actors and actresses in the first cover in the notebook. When my parents buy me a notebook in elementary level, right? And you choose, oh, this one is good because this actor or actress, I love this, like that. Because there are 2 types of notebook, the spring and the other has no spring, right? But for me, I will go to the mathematical kaloka. And then that's the time I will memorize. Since elementary talaga, memorize ko na talaga siyang mga ganun-ganun. Chuva-chuchu. Okay? And it's there also, the density, ganun-ganun, 62.43 pounds per cubic feet, the density of water, blah, 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 and everything. Okay. And you should be, what do you call this one? Resourceful. Okay. You should not wait for your teachers and instructors to push you to learn something. Okay. 2,000 liters per hour is the volumetric flow rate. Guys, now we will establish consistency because one requirement to solve problems, guys, is to establish consistency in your units because it will never help to simplify your formulas and equations or your solutions if you will never consider the consistency, quantity per quantity, unit per unit, so that you can cancel out the unit and it will become simplified and you will reach to the quantity or to the unit that asked in the problem. Okay, that's the one technique and strategy also. If you want to convert first before substituting to the formula. Because it will create also confusion somewhere along the way when you write. And ting, 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 ting. Daghang kay mga baglis-baglis, maglibog-pug ka. Okay, so it's better to convert first and plug in or substitute the result in the formula. Okay, not you go there, substitute at the same time the unit also. Sometimes it will, no, it's a minor thing, but para nako libugon man kay ko, I need to convert first. So that when I substitute that to the original equation and formula, it will not create confusion with me during the cancellation of the units, what will happen, something like that. Okay, the exponential, ganyan, chuva-chuchu. Okay? Muna akong ginabuhat sa college. Convert first before substitution. Okay? Okay, the others, they will never convert first. They will incorporate really in the formula. Maglibog magud ko. Okay? So that's my point only. For my personal convenience, ha? Okay? So that's it. It's up to you. What is your comfort and convenience on how to solve problems? But in my case, I have to convert first so that it will become simplified and then it will be plug-in. Plug-in meaning you have to put or substitute in the equations. Okay? So it's easy for me to understand visually the units to what is being asked in the problem. Okay, so 2,000 liters per hour is a volumetric flow rate. So this is volumetric. My gosh. Ba kay ko eh. Volumetric flow rate. Ganon. Now guys, if we say volumetric flow rate, so of course we need to extract the formula for this because it's being specified in the problem. Or else, I can never solve it. I will never extract the formula of volumetric flow rate. Now, in chemistry, general chemistry lecture 1 or 2? I think so. This is going to be expressed in 2. General chemistry lecture 2. First year college. This is already discussed in high school but not that rigid. Only simple, chuba-chuchu. But in college, it becomes a little bit complex like that, but still manageable. So volumetric flow rate, what is the formula for this? Hala. Stock knowledge. Volumetric flow rate, since nahibaw ka nga na volume. Unsa man to mga formula nga na mga volume sa babaw, sa ubos. Mo din mo kan sa imong una-una. Not necessarily na imong gi-memorize. Okay, basta na-ikuan sa ko, makancel biya siya. Ganun. So, magkuha ka mag-wild imagination, okay, and critical thinking, the attitude and character of a scientist and engineer. You should be having a critical thinking and wild imagination. Okay, so now, okay, volumetric flow rate, so there's a volume there. Okay, ganon. So how can I do this? Okay, so volumetric flow rate. For example, you did not memorize, you forgot. Because that was long time ago, 25 years ago. Okay, now you have the word rate. Okay, the rate having times, seconds in the denominator. So it is expected that one of the quantities of your formula have times and second. And what quantities that have times and seconds in the denominator, the numerator? Bingo, you can really understand. So, ganon siya. Okay, so volumetric flow rate. Ganon. Unsa man siya? Okay, density. The density has volume. Okay, has volume in the denominator. Possible I can use this because this is volume. Okay, i-try na to ang density. Ganon ba kung makalimot ka sa formula, nga naon mo paguna-una. Okay? Okay, lisod na sa kanay memorya ra ka sabot. Okay? So, ganon siya. Okay. So, volumetric flow rate, so understood there must have a unit of volume in your equation. Okay, now, so consider density. 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 Now, what is the partner of density? If I have the density, kilogram per cubic meter, and I have the flow rate, what is other equation that have ganon? Ganon siya. So, i-try ni mo ang area. Okay, i-try ni. Try pa ni ha. Kaya ako sa nakalimot man ko. Really. So, ato siyang i-derive. I have no choice. I did not memorize that plainly. Okay? So, that's why I need to derive. Kalimot yung ko tinuod kay lain man nga topic good. Okay. Kaloka. So, technique siya. Technique. Okay? So, density times A. Oh my gosh, ano sa itong density? So, kilogram per cubic meter. And then, area. Ano sa man ang area, guys? Square meter. Oh my gosh. Like that. Okay? Square meter. Naka-density. Okay, ganon. And then, what else you will pair this one? Unsa yung mga quantity? What quantity, guys, that involves second in the denominator in physics? So that we can come up with a rate. As I told you, rate have seconds, minutes, hours in the denominator. And we have hour in the denominator in the volumetric flow rate. So it is expected that we have also a quantity that has a rate in the denominator. So it's very easy already. We have the speed and the velocity. Okay. So, i-multiply pag yun natin siya speed. So, density times the area times the velocity. Okay, so the velocity is meter per second. Okay. Ganon siya. Assuming lang niya, nakalimot ko sa formula sa volumetric flow rate. Okay. Now, density times area times velocity, I will do now the cancellation of units. Okay. Okay, cubic meter, cubic meter. Oh my gosh! This is kilogram per second. And this is not volumetric flow rate. So this is mass flow rate. Okay, at least nag-create na taglain na mass flow rate. Kaya atong target volumetric flow rate. So it help also. Because our required here, it teach us to solve the mass flow rate. So bingo, we have now the mass flow rate here. Okay, so things like that. Okay, because I forgot the formula also. Okay, so kilogram per second is the mass flow rate unit. So this, at least you have now the mass flow rate. So the mass flow rate, density times area times the velocity. Now, to make it volumetric flow rate, okay, so it should be cubic meter over seconds. I have to eliminate the density. So it becomes simplified if you have the volumetric flow rate. So sa to pa guys, volumetric flow rate is area times velocity lang yun siya without considering the density. Because if you multiply the area with the velocity, it will have cubic meter per second, in which cubic meter is a unit of volume. That's why we have volumetric flow rate. Why? There's a flow because it's a motion, it's a movement from one point to another point by these molecules. Okay? It is the molecule will move. Okay? Molecular energy will move, huh? You get the point? So there's a movement, there's a motion, then bingo, there is a velocity. Okay, so that's why in distillation column is also a motion of toluene and benzene going up, going down, going up, going down. Because we are mentioning here the volumetric flow rate and the mass flow rate. Okay, so these quantities we obtain here, we will be using that here in our problem because the volumetric flow rate, which is 2,000 liter per hour, was mentioned in the problem. Okay, like that. So volumetric flow rate is equals to area times velocity. Okay? Things like this, you can easily remember and derive. But sometimes, mga good guys, there are equations very complicated. You cannot derive by 10 seconds, 1 minute, 2 minutes. Then, no choice, you have to memorize. Okay? What is the example? Navier-Stokes equation, Schrödinger equation, okay, Albert Einstein equation, John Clerk Maxwell equation, okay, the equation of photoelectric effect, the equation of particle wave duality, okay, the equation of momentum transfer, by Euler's equation, okay, like that, Fourier's law of conduction equation in heat transfer or in a mass transfer. So you have to memorize because there's no time to derive for that because it involves calculus and differential equation to arrive to the final equation that we will be able to use in that particular problem solving. Don't tell me you need to derive pa. And then the time will be consumed during the one problem in the board examination. Nga. Yan na proctor. Time is up. Nag-derive pa ka. Okay? So you should not depend on your, your analytical ability. That I know how to derive that. Yes, you know how to derive that. How much time you consume for the derivation, and the examination is time limited. Okay, so no choice, memorize. That's why adequate memorization is very helpful after understanding. Okay, get the point? Here, simple man siya, so I can really derive. Okay? But what if involves differential and integral calculus? How can I do that? Limit of like this, like this. Kaloka. Okay, musurrender jud ko ana. Okay, I don't have time to do that because anyway, the purpose only is to achieve the same answer. You will also feel that in your college engineering curriculum that, di ba, our instructor using differential equation, using differential calculus, using DE, integral calculus, and using algebra. This or all techniques will yield the same answer. But why you will go to the difficult? Go to the algebra. Because it will just yield the same answer. And algebra is not difficult compared to integral, differential calculus, and differential equation. Why you put headache in your mind that you are always fan and loving of solving calculus to get the answer? Use the algebra. Okay? So it's very easy. Okay? Something like that. Not very easy. Comfortability matters. Okay? So, that's it. Get the point? Go to the most simplified lang talaga siya. In my part, ganun talaga ako yung pinaka, kasi po, hindi ako magaling sa mathematics. Okay? That's why. Di palusot ako, no? Okay, but, it sounds realistic na sa good, okay? That's gonna be the point. Therefore, we conclude by derivation on the spot that volumetric flow rate is equals to area times velocity, mass flow rate is equals to the density times the area times the velocity. And guys, this is very useful in Bernoulli equation. Bernoulli theorem of momentum transfer fluid mechanics. Okay? Like that. Okay? It's movement good siya per me sa mga liquid in the orifice meter, like that, in a pipeline, in the, what else? In a nozzle, okay, venturimeter, like that, okay, so you have to take note for this, Okay, now, going back to the main topic. Now, guys, we have specific gravity. So what is the formula of specific gravity in our elementary level of education? Gitudlo na ni siya, guys, in elementary pa ta, sa grade 6 or sa grade 5. Basic science, specific gravity of a substance. And then it will be taught again in high school. And again, it will be taught in college. Shoutout ito, Master Annie. Okay? Especially if our course is science course and engineering course. Okay? Na-related siya sa science. So, doklon gyud ta mo kunin mo kay sa specific gravity. Okay? What is the formula of specific gravity of a substance? Okay, the specific gravity of a substance is equal to the density of the substance over density of water. Something like that, okay? The basis is the water, right? Okay, specific gravity of the substance is equal to the density of the substance over density of the water. Now, kung maglibog na punta, okay, maglibog na punta ni ini higayon na, kay puros raba density imong over na may chance na mabaylo unsa man nimo ni pag-attack. Okay? So let's try na pod. But what I understand ni pilit sa akong brain cells, kuan siya, specific gravity of a substance is equal to the density of the substance over the density of the water. What if mabalipod ni siya kay nakalimot ko? Okay? Let's try nga naa sa akong brain cells. First, specific gravity of the mixture is equal to the specific density of the substance over the density of the water. First basig sakto di ay. Okay? Usay mo gud mabaliman pod gud siya. Especially pareho ang quantity. Density ba sa numerator, density ba sa denominator, di ba? May chance nga mabaliktad. Okay? Especially if you are taking your course, it was 15 years ago. It's a very, very long time, right? So maybe it will change, right? Okay. Specific gravity, let's try. Specific gravity of the feed mixture, okay, is equal to the density also of the substance, meaning the density of the feed mixture na. Okay, density of the feed mixture, chararat, okay, over the density of water. Now, guys, okay, if specific gravity chuva chucho, you have the density of water in the equation. Permanent. Okay? So, ipasok din sa imong brain cells. Pag specific gravity, naagit tayo reference na density sa water. Okay? Muna siya ang nahitabo. At standard condition. Now, guys, in distillation, what you notice in the distillation separation process? Diba? Dependent siya sa temperature and pressure. You got the point? Wala din siya nag-mention ng mga temperature and pressure chuba-chucho, right? Because it will not matter. It will become negligible and constant somewhere along the way. That's why we don't need to consider that parameters here. It will not affect. Okay? So, kinabi at specific gravity of the feed mixture, dapat unta mo account sa temperature, sa pressure. Kaya kaning mga density sa water o sa mga mixture, naaman na siya at certain temperature at a certain pressure. Nananawa man tani ko ani, refer to that. Because, ing ani gani nga problem guys, mugota sa standard values. Okay, unless the temperature is given here. But there's no specification man sa temperature here. So, automatic, use the standard temperature. Could either be 25 degrees Celsius, okay, at room temperature, and also the 4 degrees Celsius, which is the reference for the density calculation of the pure substance water. Okay, I want this to emphasize over and over again and a million times. The standard temperature of the density of water being used in our previous science tests a long time ago is 4 degrees Celsius. It's not 25 degrees Celsius, which is not the same with other also in physical chemistry, in the enthalpy heat of formation, blah blah blah, so on. So our standard condition for temperature is always 25 degrees Celsius, but in density is different. That is 4 degrees Celsius. Okay, that's why we have 1 grams per ml. That's why we have 1,000 kilogram per cubic meter. That's why we have 62.43 pounds per cubic foot or feet. Okay, because of it was measured at 4 degrees Celsius and 1 atmosphere. Okay? So, dapat makamaupod ta. Sabi mga reference aning anong na standard ni siya. Di jud siya enough nga i-memorize ng lagi nimo. Ang value dapat mahibaw jud ka ba sa mga conditions or parameter. Ano nga naman jud ang constant. Ganon. Tukion nimo ba? Okay? Na apa na ikaw man mo tuki makasabot naman kaniana. So mupilit na sa imong brain cells. Okay? Very clear. Okay, now specific gravity and feed mixture is equals to density of the substance or the feed mixture over density of water. Now, we have the density of the feed mixture. It was not mentioned, but there is a specific gravity. Wow, gravity. Slang rasad kayo gravity. Oh my gosh. Thank you for watching. Okay. So my God, nalubat yung kusig yaw-yaw, oy. Saan man ako ni ini? Charot. I will pause for a while and I will go back to my second segment. Okay, of how to calculate this problem. Actually, guys, this is Chemical Engineering Board Examination, May 1996. Okay, this is a compilation of board examination tests, questions in the Philippines. Okay, not in other countries. Okay? Like that, administered by Philippine Radiation Commission or PRC. Okay? What's that? What's happening? Oh my gosh. Kaloka. Napuno dyan akong brain cells sa mga topics. Nakaloka,